Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 29 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2411, smallest subarrays with maximum bitwise OR. Let's read the problem statement. You are given a zero indexed array nums of length n consisting of non-negative integers. For each index I from 0 to n minus 1, you must determine the size of the minimum sized non-empty subarray of nums starting at I inclusive that has the maximum possible bitwise OR. Okay, OR operation, right? So if two bits are 0, output is 0. Okay, if any one bit is 1, okay, then output is always going to be 1. Okay, and here if both the bits are 1, then also output is 1. All right, so this is nothing but your bitwise OR table. Okay, done. In other words, let Bij, okay, be the bitwise OR of the subarray nums I to j. Okay, you need to find the smallest subarray starting at I such that the bitwise OR of this subarray is equal to max of Bi to k. Okay, right? So max bitwise OR, this is what we need. Okay, so I will explain this line with an example. Okay, so here if you see, this example number 1. Okay, this is my nums array, right? And here 1. Okay, after that, if you take 0, then the bitwise OR of 1 and 0 is nothing but 1 only, right? Okay, so how you write 1 in a binary form? You write 1 like this, 0 0 1. Okay, and you write 0 like this. Okay, so here output is 1 only, right? Okay, right, done. You are starting from here. Okay, you are starting from here, this index, right? Okay, so 1 or 0. Okay, you do the bitwise OR, right? So you get 1 only. Now after that we have 2. Okay, so if I add 2 here, 0 1 0. Okay, this is how we write 2 in a binary form. So you are going to get 0 1 1. Okay, and this is nothing but 3. Okay, this is nothing but 3. All right. Okay, now here if you add 1 again. Okay, so if you add 1 again, 0 0 1, you are again going to get 3 only, right? And after this one, if you add 3 again, so again you are going to get, okay, again you are going to get 3 only, right? 0 0 0 1 1, again that is nothing but 3. Okay, so here if you do the bitwise OR until here, okay, then you are going to get 3. If you are going to do it until here, then also you are going to get 3. If you are going to do it until here also, then also you are going to get 3. Okay, so what you need, you must determine the size of the minimum sized non-empty subarray of num starting at I that has the maximum possible bitwise OR. So maximum possible is 3 only if I start from here, right? Maximum possible is 3 only, right? So it's good now if I take the this one minimum sized. Okay, now let's understand this line. In other words, let Bij be the bitwise OR of the subarray nums I to j. Okay, right? You need to find the smallest subarray starting at I such that the bitwise OR of this subarray is equal to the max of Bik. Okay, whatever the max. So max we are only going to get 3. Okay, so let's pick the smallest one. Okay, so if you are going to pick this smallest one and you are starting from this index, okay, so what is the size of that? 3, right? So that's why you are writing 3. Okay, the bitwise OR of an array is the bitwise OR of all the numbers in it. We have to return an integer array answer of size n, where answer of I is the length of the minimum size subarray starting at I with the maximum bitwise OR. Okay, a subarray is a contiguous non-empty sequence of elements within an array. All right, so now let's understand this example in detail. Okay, so the maximum possible bitwise OR starting at any index is 3. Okay, so this time I was starting from this index 0. Okay, now next time you can start from here. Okay, from index 0 or index 1. Okay, from this position again you check. Okay, so the max bitwise OR you are going to get again is 3. From here if you start also you are going to get 3 only. From here you are also going to start, then also you are going to get 3. From here if you are going to start, then also you are going to get 3. Okay, right? Okay, so if you start from here starting at index 0, the very first time when you see this 3, okay, as a bitwise OR, so the shortest array that yields it is 102. So length is 3, so that is by 3. Okay, now if you start at index 1, okay, from this 0, so in 0 if you add 2, so you are going to get 2 only, right? In this 2 if you add 1, you're going to get 3. Okay, so 0 to 1. Okay, so if you do the bitwise OR of all these numbers, you're going to get 3. Okay, so starting at index 1, the shortest subarray that yields the maximum bitwise OR is 0 to 1. Okay, now if you start at index 2, okay, so here from 2, okay, so starting from 2, only if you add 1 in this 2, okay, so 2 you write like this, okay, 1 you write like this. Okay, so bitwise OR of this is nothing but 3, right? Okay, so the shortest subarray that yields the maximum bitwise OR is this. What is the length of this? 2, so that is why you are writing 2 here. Okay, then starting at index 3, the shortest subarray that yields the maximum bitwise OR is 1 3. Okay, so 1 and 3 if you write, you are going to get 3 only. Okay, so we need max, right? So 3, so length is 2, so that is why 2 we are writing here. Okay, now if you start from here, starting at index 4, the shortest subarray that yields the maximum bitwise OR is just 3. Okay, length is 1, so that is why 1. Okay, so therefore we return 3 3 2 2 1. Okay, so I hope that you guys are clear with the example and this problem statement. Okay, so now how we are going to solve this problem? Okay, so here first let's see the constants. So n is nothing but nums dot length. Okay, n value is from 1 to 10 to the power 5. Okay, and your nums of I value is from 0 to 10 to the power 9. Okay, so nums of I value, okay, whatever the values inside is. Okay, so it can be up to 10 to the power 9. Okay, given to us, right? So here what I'm going to do here, first for int, what is the size? For int size is 32 bits, right? So this is the range for int, right? Minus 2 raised to power 31 to 2 raised to power 31 minus 1. Okay, so here 2 raised to power 30 if you do, okay, so you are going to get something like this. Okay, so 2 power 30 is slightly greater than this value. Okay, right? So if I want to represent any number in binary form, okay, so then in that case I need to use these bits, right? So this is why 30 bits are enough to store 10 per 9. Okay, since 2 to the power 20, if I do, I get this, okay, which is smaller, right? And 230 is the next power of 2, right? Okay, so a range of nums of I in the problem statement is 0 to 10 per 9. All right, so maximum value, this is what we are going to get. Okay, so how many bits are needed? Number of bits required is 30. Okay, so 30 bits are enough to represent 10 to the 9. Okay, so we are going to create one array. Okay, in the array I'm going to store the bits, okay, like in this position, if this is a set bit or not. Okay, right? So even though 30 bits are enough in code, we usually check 31 bits. Okay, 0 31 0 30. Okay, so normally we start from 0, okay, until 30, right? So we have to give the range like 31. All right, so 0 30 means 31 in total. Okay, so why this is a normal procedure. Okay, so in Java, int in Java is 32 bit signed, right? So this is a range, so 31 bits are used for magnitude. Okay, so let's understand how I'm going to solve this problem. Okay, so here you can take this example, 10213. Okay, 102 102, and then you have 1, and here you have 3. Okay, so now here, all right, so here if you see what happens in bitwise OR. Okay, in bitwise OR, let's suppose if I have bits like this, 0 0 0 0, let's suppose 1 occurs here. Okay, 1 occurs here, 0 0 0, let's say. Okay, so if I just do the bitwise order of this now, so if at this position, okay, anywhere if I see 1, definitely in the result 1 will be there. Okay, right? Because 0 1 or 1 0 or 1 1 is always going to result in 1. Okay, so if I am doing the bitwise OR of any numbers, okay, any set of numbers, right? If at any position, if I see that at this position 1 is set in the output, definitely 1 will be there. Okay, if all these are 0, definitely I'm going to get 0 only. If all these are 0, I will get 0 only. Okay, so for this one, output is 2, right? 0 1 0, that is nothing but 2. Okay, so here how we are moving. So in other words, b of ij. Okay, so nums I to j, I to j. Okay, I to j. Then here also max we need from I. Okay, starting from I to k. Okay, so here what I can do, right? So if you see here, if I am here, okay, so how I'm going to write this 3 in binary form? I can write like this 1 1. Okay, that is nothing but 3. Okay, 1 1, right? Okay, after this, okay, let's say your I is here and your J is here. Okay, let's say this I and J both are here. Okay, so now here after this there are no other number, right? From I to J. Okay, from I to K. Okay, so you must determine the size of the minimum size non-empty subarray of num starting at I. Okay, so starting at I, na? So starting I from this I, there are no numbers forward. Okay, so only this one is there, right? So if I'm starting from here, what is the max or bitwise or that I'm going to get? I'm only going to get 3 only, right? If I'm starting from here only, there are no other numbers. I'm going to get 3 only. Okay, so that's the premise that at this position what I need to return, both my I and J are at this position. Okay, so I can simply, I have to return 1. Okay, size of this is just 1. Okay, only 3. So can I write it like this? J minus I plus 1, right? So this is nothing but J is at index 4. Okay, if I just want to give the indexing here, I can say that this is 0, this is 1, this is 2, okay, this is 3, this is 4. Okay, so 4 minus 4 plus 1, that is nothing but 0. Okay, 1, right? Here I'm adding 1, right? So here this is nothing but 1. Okay, so yeah, so here I can say in my output I can say 1. Okay, now after that what is going to happen? After that, let's say my I is going to move here. Okay, let's say my I reaches here. All right, at this position. Okay, so now this is nothing but 1. Okay, how I'm going to write 1 in binary form? I'm going to write 1 like this, 0 1. Okay, this is how I'm going to write. Okay, so here I have to start from here. I have to start from here only, right? I have to start from here. Okay, 0 1, right? Okay, so here if you see, this is set. Okay, this is set, right? This bit is set. Okay, now if I see this is 0 here. Okay, I need the max bitwise or. Okay, so max bitwise or when I'm going to get, when I'm going to get any value, okay, at this particular position as 1. Okay, in the right side. Okay, in this side. Okay, so right now my I is here. Okay, and this is 0, so I'm going to going to search here. Okay, in this direction, so I will see that this is nothing but 1 here. Okay, so let's say this is my J. Okay, and here my I, right? So now if you see 0 1, okay, we have 0 1 here and we have 1 1 here. Okay, so for this one I was good. I didn't move any further. Okay, but for this one we have 0 right here, 0. So I need max bitwise or. So definitely at this position I need 1 if it is there, if it is there. So yes, I see that here in this right direction I see that there is one number in which this bit is set. Okay, so now if I do the bitwise or of these two, I will get 3. Okay, right? So that is the max only that I am going to get in this direction. Okay, 3 only. So but here my J is here and my I is here, so here again apply the formula. Okay, so J is at 4, I is at 3, 4 minus 3 1, 1 plus 1 2. Okay, so in the output you are going to add 2. Okay, this is done. Okay, now this is done, right? So now let's say this is done. Okay, so now let's say after this, let me just remove this. Okay, so now after this, let's say your I is here. Okay, so now your I is here. So 2, how you're going to write 2 in the binary form? You're going to write 2 like this, 1 and 0. Okay, so here your I is here. Okay, right now, all right, 1 0. Okay, so now here for this again, now check the number of bits. Okay, so this bit, then this bit. Okay, you have to check all the bits, right? Okay, so here in this case, if you see, this is 0, right? Okay, so now you are going to see where you are going to get 1 for very first time. Okay, because as soon as I do the bitwise of any other number where this bit is set, definitely at this position also I'm going to get 1, right? So you see that here at this particular position, if I place my J here, so here we have 0 1. Okay, so in this 0 if I add 1, okay, if I do the OR with 1, I will get definitely 1. Okay, and this bit is already set. Okay, for this we no need to check anything. Okay, so here only. So now again, J minus I, 3 minus 2 plus 1, that is nothing but 2. Okay, so here you are going to write 2. That's it. Okay, done. All right, now here, now see carefully what is going to happen here. Okay, now let's say your I is here. Okay, so now your I is here, right? Okay, so you are going to write 0 like this, okay, in binary form. All right, so now here this bit itself is not set, okay, this is not set, right, and this is also not set, okay. All right, so here you can do one thing, okay. So here for this, if you see, in order to make this, in order to make this as one, you want to move your j, okay. Let's see this, okay, let's see this first, okay. This is 0, right? So here you want to change it to 1, okay. You need the max value, okay, max value, right? You need the max bitwise OR. So definitely you want to change this 0 to 1. If you move your j here now, this here it's also 0, it is also 0, no impact, okay. So if you move here, then yes, okay, then if you see 0 and 1, it is going to make 1, okay. This is done, okay, done. So now this will be changed, okay, this 0 will be changed to 1, okay. If you do the bitwise OR until here, definitely this bitwise OR until here, definitely this 0 is going to be changed to 1, okay, done. Now what about this 0, okay. So here again check, here if this is 1 na, so only until here if I do, only until here if I do, then I will be able to update this 0 to 1, okay. For this 0 I can do until here, for this 0 I need until here. So among them, what is the max? So max is this chain, so let's take the max one, okay. Let's take the max one, right? So if you just take this now, so then this will not be changed, okay. So if you take complete, then both will be changed, okay. So let's see 0 0 1 0 and here 0 1, okay. So you are going to get 3 only, 1 1, okay, 1 and 1 here, okay. So your I here, j here, so j is at 3, I is at 1, 3 minus 1 2, 2 plus 1 3, okay. So 3 is your output, right? Done. Okay, now here you reach here, okay. So now let me just move it, okay. So now your 1 is nothing but you write it like this, 0 and 1, okay. So now this is set, okay, no need to check further, okay. This bit is also set, okay. So I want to set this, so this is where I'm going to get 1 first time, okay. This bit position set here, okay. So now in this part, okay, so j here and I here, so 2 minus 0 2, 2 plus 1 3, okay. So this 3 3 2 2 1 is our output, okay. 3 3 2 2 1, all right. So now let's see how we are going to get the output, okay. So this is output that we are getting, but let's see the debug status, okay, what we need to do. So here this is your nums array, right, okay. So here you are going to just create one this position of array, right. So we need to take this 31 bits, okay. So we are just going to create a one array, okay. So this is nothing but 0 position 1, position 2, position 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, okay, until 30, okay. So 0 30 means 31 in total, okay, starting from 0, right. So we are going to create one this position array, right, and I'm going to set all the values to -1, okay. So this is going to be my first step, right. Then this is my array, right, 1 0 2 1 and 3, okay. So now here what I'm going to do, I'm going to start from here, okay. So processing index I is equal to 4, okay. So we have this number 3, okay. So in this 3, if you remember how we represent 3 in binary form, we represent it like this, okay. So here bit 0 is already set, okay, and bit 1 is already set, okay. So here both are set now. So what I'm going to do, I is also here, j is also going to be here only, right. So I'm going to update my answer as 1, okay. Answer formula is nothing but j minus I plus 1, okay. This is what you can apply, okay. J minus I plus 1, okay. So this is what you need to do, right, okay. So here 0 position, okay. Where is the bit at 0 position is set for very first time? 4 only, okay, here only. And where is the this position where 1 is set for very first time? At 4 only, okay. I'm starting from here, so from here if I'm starting, so this is my very first position, okay, where both the bits are set, okay, right, done. So here I'm just going to update this, okay. Now after that I'm going to process this. Processing index I is equal to 3, nums of I value is equal to 1. So here how I'm going to write this 1 like this, okay. So here bit 0, okay. So 1, how I'm going to write 1 in binary 0 1, okay. So here if you see bit 0, set. Okay, this bit is 0 is set. Okay, so this is set now. So where this bit is set for very first set. Okay, so I'm moving backwards, right? So at 3 it is a set where for very first time. So I'm updating this 4. Okay, it was 4, now I'm going to update to 3. Okay, now check this. So this bit is set for very first time here. Okay, at this position. Okay, so here bit 1 is not set. Okay, first, and weight is set for very first time. So position of bit. Okay, so here this bit, okay, at 1. Okay, so pose of 1. So pose of 1 last time was 4. Okay, so I'm going to get that at 4 this bit was set. Okay, so that is why I'm using this. Okay, so we are going to just update my j is equal to 4. Okay, then final j is equal to 4, I is here, so update answer as j minus I plus 1. Okay, so you are going to get 2. Okay, so here you are going to update pose 0 and this possible. Okay, and rest all are minus 1 now. There is no need to check. Okay, if they are minus 1. Okay, only if they are not minus 1 then we need to update. Okay, if they are minus 1 there is no need to update. All right, now here processing index I is equal to 2. Okay, so here we reach. So how we write 2 in binary form? We write it like this, 1 0, right? So bit 0 is not set, so where this bit is set for very first time, so you will see that this 3, okay, from previous not set, so check here. Okay, so j is equal to 3. Okay, bit 1 is set, so this. Okay, so just you are going to update this, so you are going to get this 3 2. Okay, so same way you have to check for all others. Okay, here if you see now it is important. Okay, so at index I is equal to 1 you have 0 0. Okay, so here if you see both are not set. Okay, so bit 0 not set, so here j position is 3. Okay, position of bit is equal to 3. Bit 1 is not set, so position of bit is 2. Okay, so but we need to keep j as max only, right? 3 and 2. Okay, this bit 0 was set very first time at 3, this bit 1 was set for very first time at 2. Okay, so you need to take max among them as j value. Okay, 3, so j minus I plus 1, so that is nothing but 3 minus 1 2 plus 1. Okay, 3, you're going to get this. Okay, and then you have to process this and this is your final answer. Okay, so this is for example number 2, I think. Okay, example number 1. Okay, example number 1, right? Now same way for example number 2, these are the debug statements. Okay, so you can just try to solve it by yourself. Okay, very easy, only two numbers are there, so these are the debug statements for example number 2. Okay, so now let's write the code. Okay, so code is going to be very simple. Okay, whatever I have explained I'm going to write the same thing. Okay, so first what you need to do here, just calculate the length of your nums array. Okay, so here int n is equal to nums dot length. Okay, done. And now once this is done, then after that here what you need to do, just write create one post array. Okay, int post is equal to new int, and here just pass 31. Okay, so 0 30, right? We need all these bits. Okay, so 31 I'm going to pass, and here I'm just going to fill all with -1. Okay, so arrays dot fill. All right, and here -1. Okay, this is done. And then here I have to write answer is equal to new int. Okay, and here I'm just going to pass n, and then after that here I have to reverse. Okay, I have to start from the last index. Okay, so int I is equal to, here I'm just going to write n minus 1. Okay, and I is greater than equal to 0, and here I minus minus. Okay, and here int j is equal to I. Okay, this is done, right? So initially I'm setting j as I only. So now after that I'm going to check the bits. Okay, so for int, okay, so here I'm just going to write bit. Okay, 0 bit is less than 31. Okay, I'm going to check for all. Okay, and here bit plus plus. All right, and here I'm just going to check if that particular bit is set or not. Okay, so how I'm going to check that? If I'm going to take that particular nums of I value. Okay, done. And okay, for this nums of I, I'm just going to do the and with. Okay, and with. Okay, and here inside this 1, and I'm going to left shift it with bit times. Okay, so if the output of this is comes to be 0,
That simply means that this bit is not set. Okay, if this bit is not set, I'm just going to check if that position of bit, okay, if this position of bit is not equal to -1. Okay, if it is not equal to -1, then only I need to get the j value. Okay, that means that in the past I have seen this set bit. Okay, so j I'm going to update as math.max of j, and here position of this particular bit. Okay, right. Okay, and here else part, here I'm just going to update position of bit, okay, as I. Okay, else part. All right, so if this bit is already set, then I'm just going to update the best position, okay, where that bit is set for very first time. Okay, and why we are using this math.max, so I have already explained here. Okay, so here first time position of bit not set, so we were getting 3. Okay, here also bit 1 was not set, so position of bit was getting 2. Okay, so but we need max 1. Okay, so that is why I'm keeping here math.max. Okay, that's it, and this is done here. And how you're going to update your answer at this particular I index, you're just going to update it as j minus I plus 1. That's it. Okay, and in the end just return answer. That's it. Okay, return answer. Okay, so now let's run the code and see if there any code issue. We'll try to fix that. So yes, so there are some issues, so let's fix that. J minus I plus 1, right? Okay, anything else? Here also I think it's saying something. If nums of I and 1 website width. Okay, yeah, okay, this needs na. All right, now it looks good. Okay, now let's run it again. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.